Isn't it incredible that everything around us, our bodies, buildings, liquids, gases, mountains, donuts, and I love donuts, are composed of the same tiny atomic building blocks called atoms? It's even more amazing that there are only 92 different types of atoms. It makes you wonder, how can so much diversity come from such a small set of building blocks? This is Real Chem. My daughter has a set of Legos that I try in vain to keep organized. I name them by their size and color: blue 2x3s, red 3x4s, etc. You know, a nice, concise notation. Chemistry also has a concise notation for its building blocks. Let's explore. Atoms are composed of only 3 types of subatomic particles: protons, neutrons, and electrons. All protons are identical. Likewise, so are electrons and neutrons. And what makes one atom different from another is the number of protons contained in the nucleus. The protons and neutrons reside in a tiny nucleus, 1/1,000,000th the volume of the atom, and they are surrounded by electrons. Nearly all of the mass of the atom comes from the nucleus. But that doesn't mean electrons aren't important. Chemistry really is all about the electrons, because chemical processes never alter the nucleus. As we build things with atoms, electrons move from one atom to another, or be shared among atoms. But the nuclei don't change. That's why it makes sense that our notation for the atom focuses on the nucleus. All it takes to uniquely specify a given atom is its number of protons and neutrons. This nucleus has 3 protons and 4 neutrons. Each proton has an electric charge of +1, while the neutrons have no charge. So the nucleus has a total charge of +3. We call this the atomic number, or Z, which is equal to 3, and it tells us the identity of the element. From the periodic table, we find that Z equal to 3 corresponds to lithium, with a symbol of Li. The proton and the neutron have nearly equal masses, so the mass of this nucleus is related to the total number of protons and neutrons, or 7. We call this the mass number. Electrons have a charge of -1. So if I surround this nucleus with 3 electrons, the net total charge on the atom is 0. We say the atom is electrically neutral. Let's compare this to an atom with 1 less neutron. The atomic number is still 3, so this is still a lithium atom, but the mass number is now 6. So why do we refer to both of these as lithium atoms? Well, this is because the chemical behavior of the atom is most related to the charge on the nucleus. The neutral form of both of these atoms has 3 electrons, and this sets its chemical properties. For example, one of the most important chemical properties of lithium is that it tends to lose an electron. So when this happens, the net charge on the atom becomes +1, +3 from the protons, and -2 from the electrons. And we show this as a superscript 1+. As for the neutrons in the nucleus, they have no effect on this property or any other chemical property. We refer to lithium with different numbers of neutrons as isotopes. A sample of lithium will contain a mixture of both these nuclei, and because these have nearly identical chemical behaviors, we almost never separate them. Instead, we work with the mix of isotopes nature gives us. So when we write Li without specifying the mass number, we mean the naturally occurring mix of lithium isotopes. Getting comfortable with the notation used for atoms is important. It is a way of keeping track of the differences that define all the variety and diversity around us. It is part of the language of the building blocks that come together to make the world we live in and that make us. So explore and remember to have fun.